Welcome in Tilco Advisors. We empower construction material manufacturers with cutting-edge digital solutions. And now, welcome to our podcast, where we share insights from the world of smart construction technologies.
Today, we are opening up a file that, I'll be honest, usually makes people want to run for the hills. We're talking about data templates. And not just any data templates, but the specific granular standards that underpin the construction industry.
It does sound a bit like homework, doesn't it?
It sounds like the kind of thing you ignore until the lawsuit happens.
Yeah.
But here's the thing, and this is why I actually wanted to do this specific stack of research. We have been promised interoperability in construction for, 20 years now?
Oh, at least.
We've been hearing BIM is the future since I was in short pants. Yet every project I see is still just a mess of disconnected spreadsheets and people yelling at each other in PDF comments.
That is painfully accurate. The promise of the digital twin has been there, but the reality is often just a digital silo.
Exactly. So the mission today is to figure out if we are finally fixing that Tower of Babel problem. We've got a stack of heavy hitters here, technical standards from ISO and CEN, some really good insights from Trod BIM, and research from Building Smart. And the argument they all seem to be making is that product data templates, or PDTs, are the missing link.
They are the bridge. They have to be.
But I have to play devil's advocate right out of the gate. Why is this the solution? I mean, why isn't this just another layer of bureaucracy that architects and engineers are going to ignore?
That is the multi-billion-dollar question. And to answer it, we have to look at what's broken in the current workflow. The core issue isn't really the software anymore.
Right.
It's the language. You have architects, engineers, manufacturers, contractors, and, facility managers all trying to build the same building, but they are speaking completely different digital languages.
Okay, so an architect puts a generic window in their model.
Yep.
The engineer calculates for a glazing unit. The manufacturer sells a product X500.
And the facility manager, 20 years later, is just looking for
that glass thing that's leaking.
Precisely. And the computers have absolutely no idea those four things are the exact same object. The source material we're looking at today frames this as the ultimate interoperability gap.
Right.
So the goal of the product data template is to create a kind of Rosetta Stone that forces all those actors to agree on what that object is before a single brick is laid.
Okay, so let's get into the weeds. We all know BIM. We don't need the BIM 101 lecture here. We know it stands for Building Information Modeling.
Or management.
Right, but let's be real. 90% of the industry treats it like 3D drafting on steroids. It's geometry. It's pretty pictures.
It is Hollywood BIM. Looks great, contains almost no useful data.
Right, but the I in BIM is supposed to be information, and ideally, management. The Pro-D-BIM overview we have makes a huge point of this. It's not just about the 3D shape. It's supposed to cover 4D, which is time and scheduling, and 5D, cost.
And even beyond that, the life cycle view in the research shows the full circle. Conceptual design, detailed design, fabrication, construction, all the way to operation, renovation, and demolition. The data needs to survive that entire journey.
Cradle to grave, or cradle to cradle if we're being optimistic about recycling.
Exactly. But here is the glitch in the matrix. The manufacturers, the people actually making the boilers, the chillers, the windows, they have incredibly detailed digital catalogs. They know the thermal capacity, the acoustic performance, the exact dimensions.
And the designers have their BIM models, usually in an IFC file.
Yes. But when the designer asks for heat output, and the manufacturer's database calls it thermal capacity, the software just sees a mismatch.
It's a computer says no moment.
It is. The computer says, I don't know what you want. So usually a human has to step in, read a PDF, and manually type the data into the model.
Which is where the errors happen.
Yeah.
That's where you type 500 instead of 50, and suddenly your HVAC system is sized for a stadium instead of a house.
Correct. So the product data template, the PDT, is designed to eliminate that manual error-prone translation.
Okay, so let's unpack the PDT. The research references ISO 23387 quite a bit here, and it uses this analogy of a skeleton.
Yes. Think of ISO 23387 as the standard that defines the structure of the data. It doesn't tell you what the data is, but it tells you how to organize it. It really does provide the skeleton.
Okay, but skeletons are spooky.
Yeah.
Let's put some meat on the bones. What actually goes into a PDT? Because I'm looking at the co-builder source here, and it's It's intense. It's not just a list of properties. It's what they call the DNA of data.
Well, it has to be intense to work. If you want a property to be machine readable, you can't just have a text field where someone types 50 kilograms.
Why not? I know what 50 kilogram means. You know what it means.
We do. But a computer in the US might think 50 means pounds. Or it might not know if kg is a unit of mass or force in a specific context. So the template requires these very specific attributes to lock this down. And the most critical one is the GUID.
The globally unique identifier.
Yes. Every single property, not the product, the property itself, needs a unique alphanumeric code that is the same everywhere in the universe.
Okay, hold on. I want to push on this. Why does it matter if my thermal conductivity property has a GUID? Isn't that just IT pedantry?
It's all about risk management. Imagine a scenario, say, 5 years after the building opens. A fire damper fails. The facility manager looks at the digital model. If there's a GOD attached to that damper's performance data, they can instantly trace it back to the exact manufacturer's batch, the warranty info, the installation date, everything.
And if there isn't a GUID?
Then they have a generic object just labeled damper. They have to go dig through paper archives or old emails to figure out who even made it. The GID is the digital thread. It's the difference between a warranty claim you win and a lawsuit you lose because you can't prove what was installed.
Okay, that makes it real. It's the breadcrumb trail.
Exactly. And the PDT also handles the linguistic data. It ensures that the GUID for thermal conductivity maps to the English term, the Norwegian term, the Japanese term. So if I'm a German manufacturer selling to a French project, the software automatically knows that my Wärmeleitfähigkeit is the architect's Konduktivität thermique.
No more Google Translate disasters.
No more disaster.
Right, I'm sold on the skeleton. But the research mentions this standards triangle from Building Smart. And I'll be honest, when I saw the diagram, my eyes glazed over. It's just a soup of ISO numbers. 16739, 12006, 23386. Can we make this human?
We can. Let's try to visualize it using a single object. Let's stick with your fire damper.
Okay, I have a fire damper. It's sitting on my desk.
Right. Now first, we need a standard to tell us what this object is. We need a dictionary that defines fire damper, so everyone agrees on the term. That is ISO 12063. That's the dictionary.
Got it. The dictionary says this is a device that stops fire in a duct. Simple enough.
Right. Now we need to ask questions about it. We need a form to fill out. That is ISO 23387. That's the product data template. It arranges the dictionary words into a structured questionnaire. What is your fire rating? What is your size?
Okay, so the dictionary gives us the words and the template arranges them into sentences, into questions.
Exactly. The manufacturer then answers those questions, creating a product data sheet. Now, where do we put that completed sheet? We put it on the digital shelf. And that shelf is ISO 16739, which is the IFC file format. That's the file that holds the entire building model.
I like that. Dictionary is what is it, template is what are its specs, and IFC is where does it live.
Perfect.
Yeah.
But there is one more vital piece of the puzzle mentioned in the sources. ISO 23386.
Ah, the governance standard.
Yes, because here's the danger. What if I don't like the dictionary definition? What if I want to invent my own property called super cool fire rating?
Then we're right back to the Tower of Babel.
Exactly. ISO 23386 is the rule book for who is allowed to change the dictionary. It governs the authoring and maintenance. It ensures that we don't end up with 50 different definitions for the word height.
So it prevents the Wild West scenario where every manufacturer makes up their own terminology to sound better.
It enforces discipline. And frankly, without ISO 23386, the whole system collapses back into chaos.
That brings me to the why now part of this deep dive. Yeah. Because we've had dictionaries before, right? We've had templates. But the research pivots hard to sustainability here, specifically to ISO 22057.
This is the game changer. This is the killer app for data templates.
Okay, connect the dots for me. How does a data template save the planet?
It all starts with EPDs, environmental product declarations. These are basically the nutrition labels for building materials. They tell you the carbon footprint.
But historically, EPDs have been static PDFs. I've seen engineers with dual monitors, one with a 50-page PDF and the other with an Excel sheet, manually looking up global warming potential and just typing it in.
It's a nightmare. It's slow, it's expensive, and nobody wants to do it. So sustainability becomes this nice-to-have report you run at the very end of the project, just to get a certification. It doesn't actually drive the design.
Because it's too hard to calculate while you're designing.
Exactly. Now, enter ISO 22057. This standard makes EPDs machine-readable and machine-interpretable.
Okay, machine-interpretable is a big phrase. What does that look like in practice?
Okay, imagine an architect is designing a wall. They currently have it set as concrete. They want to see what happens if they switch to mass timber. In the old workflow, that's a week of emailing consultants and recalculating.
Hey guys, could you rerun the numbers for me?
Right. With ISO 22257, the BIM software pulls the specific product data template for the timber, which contains all the EPD data. It reads the production impact, that's stages A1 to A3, the construction impact A4 to A5, and the end of life, stage C. And it updates the carbon score of the entire building in seconds.
Wow. So it turns carbon from a compliance report into a design parameter. You can design for carbon the same way you design for cost.
Yes, and that is only possible because of the connection between the BIM model and the PDT. The PDT is the pipe that delivers that environmental data into the model in a format the software actually understands.
That is genuinely cool, but again, I have to be the skeptic. Is this all theoretical? Is anyone actually doing this, or is this just standards bodies high-fiving each other in Geneva?
It is happening, but it's hard work. The sources highlight Piero BIM as a prime example. This is an initiative driven by the Eurovent Services Company.
And they picked the hardest possible difficulty level to start with, HVACR, heating, ventilation, air conditioning.
It really did.
So why is HVAC the boss fight of data templates?
Because unlike a brick, an HVAC unit is dynamic. A brick is a brick. Its properties are static. But an air handling unit, its performance changes based on the airflow, the outside temperature, the humidity, the pressure drop.
So a static PDF EPD is basically a lie for an HVAC unit because it only shows one specific operating condition.
Exactly, it shows a snapshot. But to model a building's energy use over a year, you need the curve, you need the logic. Piero BIM is working to harmonize these complex product properties so manufacturers can set up their PIM systems, their product information management, to export this dynamic data.
So the PDT has to be smart enough to say, if the temperature is X, then the efficiency is Y.
Yes. And Piero BIM is proving that you can map these complex behaviors into that standardized structure we talked about. It allows manufacturers to create a single source of truth. They update their data in one place, and it propagates out to every BIM model using their products.
This leads us to the concept of the Digital Product Passport, or DPP. The Eco-Platform source mentions this. It sounds like a travel visa for a fan coil unit.
That's a great way to put it. The digital product passport is coming, especially with new EU regulations. It tracks a product's entire journey from raw material extraction all the way to recycling.
So it's the ultimate audit trail.
And it involves big questions of access rights. Who is allowed to update the passport? Who can read it? Is the data stored on a central server or is it decentralized, like on a blockchain? The PDT is the vehicle for this passport. It carries the data.
So if we zoom out, we started this conversation talking about 3D models, but we've ended up talking about databases.
That is the aha moment. The industry is realizing that we aren't just drawing lines on a screen. We are building giant interconnected relational databases that just happen to look like buildings.
And the product data template is the grammar of that database.
Correct. The connection is BIM provides the context, the building, and the PDT provides the content, the product. Without the PDT, the BIM model is just a hollow shell. It's a skeleton without muscles or organs.
And without the dictionary, ISO 12006, and the governance, ISO 23386, the PDT is just a jumbled mess of words that nobody understands.
You've got it. It's a stack. You need every single layer for it to work.
But this leads me to a final, slightly terrifying thought. We talk about the digital twin, the idea that the digital version is an exact replica of the physical building.
Yes, the holy grail of facility management.
But think about the maintenance required for the data. We are talking about millions of G8s, millions of properties, manufacturers going out of business, standards updating constantly.
It is a massive challenge.
If we build this incredibly complex skeleton of data, who is going to take care of it? Are we going to have data janitors for the next 50 years?
We have to. If we don't, we risk creating a zombie twin, a digital model that is so full of broken links, obsolete data, and incorrect definitions that nobody trusts it.
A pristine physical building with a corrupted digital soul.
That is the risk. The technology is here, the standards are here, but the discipline to maintain that single source of truth, well, that's a human problem.
Well, that is a sobering thought to end on. We have the tools to build the future, but we actually have to do the chores to keep it running.
Exactly.
Next time you walk past a construction site, don't just look at the steel and glass. Think about the invisible, fragile skeleton of data holding it all together, and hope someone is checking the dictionary. Thanks for diving in with us.
Thank you.
See you on the next deep dive.
That's it for today's episode. We hope you enjoyed exploring how digital workflows are transforming the construction industry. Don't forget to subscribe and join us next time for more insights into building smarter. Looking for more knowledge and inspiration? Head over to our website. You'll find everything you need to keep building smarter.